Hello and welcome back to the Code Meet in general. This time we are going to take a look at the generation or creation of automated tests for a simple site generator, simple static site generator written in Python. So as usual, I was looking at the PyDigger website and found, and I'm filtering out the packages that have a link to their GitHub repository, so it's going to be easy to find them, and that they don't have a continuous integration configured. And then, of course, I also read the documentation, the summary, to see if something that's interesting or sounds not very complex at this point. And then I noticed this one, the simple static website generator. And so I visited the website, which looks like this, the Git repository. And I noticed that it doesn't even have tests. So I figured I need first to write tests, and if I want to write tests, I first need to understand how to use it. So I looked at the README. I was looking for some examples, and I saw all kind of things, how to run it, and all kind of interesting things, but no real example here. But I found this entry saying that there is a separate branch called example where you can find the example. So I cloned the repository, switched to that branch, figure out how to generate from the input. So the example is just a bunch of input files. How to generate from that input the output, and so that's where I went back and said, okay, I can do this. I have already implemented a couple of in a couple of projects. I've implemented testing this way. So the idea is that we would have various input sets of input, so as if they were various different websites. From each one of them, we can generate the output, and we save both the input and the output. And then that's we inspect the output, checking whether the output is correct as we expect. And then the test actually is generating again the output from the same input and comparing, running a diff on the new output and the output that we already saved and inspected. Now, if we just did some refactoring or we made some changes, the authors, not me, in the code that doesn't impact the output, then that shouldn't impact the output, then the diffs should be the same. Okay, so the test will verify that our changes didn't impact the output. On the other hand, if our changes should impact the output, then we'll see the difference and we'll be able to look at the difference with diff, or look at the actual output and decide, again, inspect it and decide whether the new output is what we really wanted from the changes. And then if it's not, then of course we go on editing, or the authors are going on editing. And if the new version is the right one, then we would need to be able to easily update the expected output that is stored in GitHub, in Git. So for the next iteration, we will have a new set of expected files. So that's what I thought that I can implement here. But I wanted to make sure that it's a slight work, and I wasn't sure that the author really wants it. So I went, before I went and implement it, I went to the website, the repository. I opened an issue on GitHub, describing more or less what I want, what I planned to do, and asking whether that's interesting. And soon, a couple of hours later, I got a response from Tina, the author of this package, that in general she likes the idea, though she is worried, I guess, that it won't be the test won't be difficult to maintain, because she's planning to make a lot of changes to the code, and so on. But she also assigned the issue to me, so now it's assigned to me. So okay, I can get ahead and start doing this, and then hopefully she will like the way I implemented it, and then she can go on using this test system. So what did I do? Well, here is the source code. It's already cloned on my computer. There's a new branch. So the thing is, she mentioned as well that the two branches, the examples branch and the master branch where she's developing the code, slightly are different, and you can see that if you check the commit tree. But the real branch, the real development branch is Codemaster. So I started off from that branch, not the one where the example is. And what did I do? I created a test script, and we're going to see that test script soon. I also created a file called conftest because I wanted to add a new flag to PyTest, and we'll talk about this later as well. And I also created a couple of examples, well, two examples, a basic one and then a slightly more complex one. They are way less complex, the one she already has in the examples directory, but I thought let's start with something simple, and once the skeleton of this testing system is there, then more tests can be easily added, more examples can be easily added and used. So what we can, if I run tree on this, then you can see, well, let's run the first one. Let's make it this way. Tree on examples 0, 1. So this is how the first example looks like. It has an input directory, which is two directories in two files, and an output directory. So this was the manually I created the input directory. Then I run the module, the command of this module to generate the output. I looked at the output and I said, okay, that's, I guess, what should be there. I don't really know, but that's what I guess should be there. So I saved both of them. And then I did the same with the other one. It was a slightly more complex. Here we already have a couple more files, input files, 4 input files, and 2 output files. So that's fine. And obviously, more can be added here. So now if I run PyTest, just PyTest, it will generate the output and compare the outputs and says that everything is fine. What happens if I make some changes? So let's go to the example 0, 1, and in the input file and in the, I guess, in the content, there is this index file, and let's change this head 1 to the word new. Okay, so now if I run PyTest, it fails, and it also tells me that it's actually, you can also hear the output already. I didn't know that earlier, I didn't check it. If you run it with the -s flag, then it will give a lot more details, but here you can already see the diff. So this is what changed. The index HTML file changed, and this was the earlier version, and this was the new version. So this way, you can easily see when something changes in the output. And now you can decide, so actually, and the output, the actual output is here. You can see it's in a temporary directory, so you can inspect the whole output if you really like. But if you decide that that's fine, then you can run the PyTest with the -- save flag. Then it will pass because it doesn't actually do any real testing. What it does, it generates the results and replaces the old expectations with the new ones. So if we are checking now the Git status, then you can see that now both the input file changed, that I changed manually, and the expected output file changed. And if we run the git diff on the examples 0, 1 basic output, then you will see that basically it is the same diff as we saw earlier in the report. Well, here we have colors, but that's just the way it works. Okay, so that's basically the whole testing system. And then I also added the GitHub workflows CI YAML file that would run on the 3 operating systems and 3 versions of Python. And it would install the prerequisites, also install PyTest, which is not a prerequisite for the package, but we need it for the testing. And then we run PyTest -vs, so we'll have more verbose output in the continuous integration system. And then I push the whole thing out, and here to my fork. Okay, so here is my fork, and here are the actions, and there were a couple of steps here. first, and a couple of tests here. First, when I added the GitHub action, and then it worked at the beginning, and first example worked, and then when I added the second example, it stopped working. And actually, I knew that there is some issue, but the first example didn't show this issue. So what is the issue here? If we go there to the output of, so first of all, as you could see, on Ubuntu, they all pass. Just on Mac and Windows, they failed. So I wasn't sure what's going on. But what you can see here is that some ordering issue. So there is a list of entries, and the order is different. And sometimes, actually, I think it will also fail on Ubuntu, because this is how I noticed that it failed on my system with the original example. But here, in this case, it's only failed on macOS. So at first, I thought that, well, maybe the system, so the module itself, this Python module itself, should make sure that the order is the same on every iteration of every run of the generator. I'm not sure anymore about that. What I did is partially fix this issue and created more issues. That's not really interesting right now. What I did is, in the second example 02, input, and I think in the template base, this template, sorry, not this one, in the content index, I think that's where I had to add it. Yes, so instead of just looping over the pages and creating these list items, what I added a sorting. So at least in this example, they will be always sorted by the name of the link. Okay, so these are links where there's an href and a name, and so the links will be always sorted. And that's basically how I fixed it. This was an in-between thing, sorry. And this is how I fixed it. Now, I pushed it out, and it was still failing, but this time it's only failing on Windows. So I was wondering what happened there. And so when I look at the output, you can see that the link on one of them is post /first, which is what I expected, which is what should be there. And on the Windows version, apparently is post /, which is incorrect. Okay, so this is, as I understand, is a real bug in the system, that if you use it on Windows, then it will insert a /, which is native to Windows, but it's not correct on the URLs as a URL in the URL. So it should be / just as in the case of running it on Linux or Mac OS. So that's why I didn't try to fix this, because I think this is a real bug, and this is how I'm going to send the pull request. And now, just to get back to, well, apparently I closed this just to get back to the code to show it. So the conf test is just a way, it's always read by PyTest. So you don't have to do any explicit thing in order to load this. Here you can define various things. For example, options, additional options for PyTest. So this is how this extra -- save flag could be added. And this is basically using the syntax of argparser. So in the same way, you can add various other arguments to PyTest. And the testing itself, what it does, it takes the root is the path to the root directory of this project. And because now the test file is in the root directory, that's how we get it. So this we should be able to run it from any place. That's the whole point. And then the examples directory, this lists all the examples, just listing the older examples. And then here are the tests. Okay, so this is the test, which is parameterized by these examples. And then for each example, what we do is put together, so the test examples uses basically 3 fixtures. One of them, this is the example. Another one is the temporary. The third one is the request, which is used to get that flag, the save flag. So if you look for it, this is how we get the flag from the Git, from the PyTest system, I guess. Okay, so here we created the command that would generate from the input the output. The output directory that we used is one from the tempdir, so it will always be a temporary directory, not anything in our file system, in the directory system, in the file system of the project. And then we run OS system just to generate the new output, check whether the exit code is 0, so the process was running properly. And then there are two cases here. If the save flag was on, then what we do is remove the expected output, if there was one, and then move the actual output to the expected output. The reason we are checking here whether the expected output is really exists. So the first time you create this, you can just create the input and then run PyTest --save, and it will generate the output for the new example as well. And in this case, we call return because there's no point in comparing anything because it's just generated. So if we compare to, if we would compare, then it would compare one to itself. And anyway, we don't have the output anymore because we moved it. So that's not real testing. And the real testing, the real comparison comes here, where we use the file compare module to compare the two directory structures. And then on each directory structure, and then we go over this with this check diffs function above. It's recursively go through the whole the directory structures, compares the checks if the files are the same, and then if they are not, then uses the other package, which is where it is, and difflib here, the difflib. It uses the difflib to create the unified diff that you saw on the output. So that's it basically, I think. I hope that this video helps understanding how this testing works. And my recording is not working as I expected. Anyway, so I hope that this video helped you. And if you like the video, then please click on the like button and also follow the channel. And well, send more examples to this project, so it will have a nice series of examples, documentation, and tests for all its features. And see you next time. Bye bye.